10 years, 2 million pages long. The paperwork was $500 million.
My friend, trust the paperwork.
Okay.
This is nuclear.
Thank you so much. Thank you. Thank you. From Agerpoint, this is Intelligent Everywhere. I'm James Kotecki, recording on location at Techtalia 2025 in the Eternal City of Rome. And my guest today is Alessio Iuvara, the founder and CEO of CAELUS, which is a company that is using AI to deploy nuclear power faster and cheaper. Welcome to Intelligent Everywhere. Welcome to Techtalia. What I understand is you're using AI to make the process of getting through all the paperwork that it takes to deploy nuclear power, you're making that process faster. Is that fair to say?
Not only, but yes.
I want to give people a sense of how challenging it is to deploy nuclear power today. If someone is doing this without your help, how challenging is it to get new nuclear power out there?
NuScale Power, the only licensed small modular reactor today, have had a licensing process lasting more than 10 years. It cost $500 million and brought to the construction of a document that was 2 million pages long. You have to do this not only for one power station, but upon 60–70% for every power station that you built.
10 years, 2 million pages long.
Yes.
Was that dollar quote that you gave, was that for the entire reactor or was that just for the regulatory piece?
No, just for the paperwork, my friend.
The paperwork was $500 million.
My friend, trust the paperwork.
Okay.
This is nuclear.
Okay, so this is a great place for AI to come in and start doing some work. Tell me about how your platform works. All of us are familiar with ChatGPT. So an engineer sits down in front of a screen and is like, let me start writing some paperwork to license nuclear power. What do they see? How does it work?
Absolutely. So they have two phases of the interface. One is more like a ChatGPT, so LLMs that can answer regulatory questions, but also make robotic process automation of the creation of the document itself. On the other, there is a documental automation platform. So at the end, what the engineer do? He goes there, sits, puts the problem behind, I don't know, the licensing of a valve, of a subsystem of the reactor. The system answer, he check the answer and put the tick because all must be traceable in a nuclear kind of power project. And then this thing is used for the context engineering of the final document to be built. So it's all automated.
So it sounds like there's still a lot of human aspects built into the process. There's an engineer checking it at all these steps because this is probably the last place that you would want to have any kind of hallucination in the document.
Absolutely, yes. The nuclear regulatory body, that is actually the body that will license the reactor at the end, won't, and I repeat, won't accept something that is full automated. They need to see that there have been people that actually checked what is put out. And this is not only for licensing documentation, but also when you have a semi-automatic control system for the power plant. So it's something that is normal in nuclear.
I believe your company is based here in Rome. Tell me about the scope and the places that you're actually able to do this.
Absolutely. The idea is to make design, license, build, repeat of nuclear power plants worldwide. We started here in Europe, but with the regulatory framework of US, Canada, UK. Why? Let's say that here in Italy we do not have a nuclear power plant born from Italy, let's say. Most of the technology that we can use now are from the US, France, or even Russia and other places. But, you know, we are in the NATO bloc. So, I mean, the choice narrows. Thanks to the benchmark that we have done, based on the NuScale reactor, we are able to cut down the times and the costs from 2 to 3/5 of the whole process. That means that just on licensing is a 200 million to 300 million saving on the whole process. Why? Because more than 80% of this cost comes from like nuclear engineers, chemical engineers, whatever, used to write paper. Makes no sense. These people are very rare and cost a lot. So it makes more sense to use them to build and design the reactor.
High value people putting their time into paperwork when they could be using it to actually build the thing. So if you're cutting down on costs, how much would it actually cut down on time? I mean, do you even have an answer yet about how much faster you can make this go?
Absolutely, yes, because as I was saying before, we have made this benchmark comparing with the licensing of the NuScale reactor. And we have been able to cut down the whole process in 2 years. So design licensing part, that is 5 years, not 10, because then there is the permitting. On these 5 years, we cut down to 2.
Okay. So that's
and this is proven.
Very significant.
Absolutely. I mean, more than this. In this way, you can make micro and small modular reactor with reasonable times and cost. Otherwise, we are just taking the worth of large-scale power station without the economics of scale. Without that, you cannot do it.
Are you also now or potentially in the future going to sell similar technology to the regulators on the other side who have to actually read these documents and figure this out? And so there's going to be AI on both sides of the equation, I imagine.
Absolutely, yes. One of the most good partnerships that we have are with two nuclear regulatory bodies here in Europe. And we aim to expand this thing on the world regulatory bodies of Europe because in nuclear you need something that is called verification, validation, and quality certification. And that, especially in regulatory regimes, must be done together with the regulators. And when the regulators use your system and you are able also to help on the other part without having conflict of interest because you do not build reactors, actually you are changing the paradigm. We are shifting the paradigm with both regulatory, construction, and design of nuclear is done.
We have time, I think, for a question or two from the audience. If anyone has questions about AI and its role in speeding the development of nuclear power, now's your chance.
According to Perplexity, there are a lot of inefficiencies in the process of developing nuclear plants. Could you just enlighten us on that, on these processes, and what exactly is currently inefficient? Why we're not building them faster?
Let's make the hypothesis that in this answer we are not taking into account the public acceptance, because I cannot go in the minds of people and make them accept nuclear. But this is another story. So if we take this from granted, the inefficiency comes from not only the licensing process, that is the one that we've seen, but also on the construction process, especially related to quality for big reactors. I will give you a couple of data. In the Hinkley Point C, that is one of the EPR, the European Pressurized Reactor that was built, actually is being built, in the UK, there was a production of something like 500 engineering change requests per day. What they are? That means that when you're building something, not always the things follow the specifics. And so you have to signal them. Okay, when you have one of them, actually you have to make reparation work. Some of the documents that come and also the process that come from this type of endeavor can get wrong. And the data is about 11-12% of that. For every one of these NCR that you do wrong, you block a squad of almost 60 people, 60 for 1 week. Just scale it for a huge scale reactor and you get an idea on how much this thing can alter the possibility to have a speed process, but also increase the cost. Then there is all the regulatory part related to construction. There is also the redesign that you must do in order to be fitting with the regulatory of every country, and even on the environmental side from every place in the country itself. I mean, is a behemoth in terms of regulatory. The last part is getting a resilient and qualified supply chain. And this is also another part where we are working. These are the three monsters of nuclear, as we can say.
We've kind of had the assumption in this entire conversation that it is good for the planet. It's a good idea to build more nuclear. Maybe not everybody agrees with that, but give me your 15-second pitch. Why is it important to accelerate the pace of nuclear energy development?
Wonderful. So nuclear is often a misunderstood technology. The thing is that if we think about AI, the massive energy consumption that we will have in the next years, if we think about the growth in population from developing countries, if we think all this energy hunger that we will have, not only in Europe, in the US, I mean in the world, I mean Africa, I mean Southeast Asia, whatever, renewables, even coupled with batteries, are still not enough. And the only solution for that is to use something that can give baseload power that is not fossil. And the only technology that we have now is nuclear. Now fission, I hope in the future, as soon as possible, fusion. But I mean, we have to make the solution with what we have now. And what we have now, to be solid to give the answer that we need, is nuclear. There is no other way. Coupled with renewables, but together with nuclear. Otherwise, there is no way.
Alessio Iuvara, the founder and CEO of CAELUS, thank you so much for joining us on Intelligent Everywhere, and thanks for being at Techtalia. And thanks to all of you for listening. Really appreciate it. Thank you.
Thank you.
And thank you for watching the show. If you're watching this on YouTube, please like, comment, subscribe, whatever it takes to tell the algorithms that you want more Intelligent Everywhere. From Agerpoint, I'm James Kotecki. Let's get out there and enjoy the rest of Techtalia 2025. Thanks, everyone.